Welcome back to study room. So today we'll be studying about mass and weight. So most of you think that mass and weight are the same things, but mass is different from weight. Basically, when you say that, my weight is 60 kgs or my weight is 58 kgs, you're not telling your weight. It is basically your mass. When you say that I measured my weight on the weighing machine and my weight is 48 kgs or 50 kgs or 60 kgs. So we say it wrong because it is not weight, it is your mass, which we measure in kgs. Okay, so let's learn about weight. Weight and mass are two different things. Okay, so let's get started. So let's watch this short video to know how weight and mass is measured in space.
At home, many people can and do weigh the food they eat. It's as easy as putting it on a scale. But scales don't work without gravity. So, how do astronauts measure the weight of small items in a microgravity environment like the International Space Station? They measure mass instead. What's the difference? Mass is the measure of how much matter something contains. Weight, on the other hand, is the measurement of the pull of gravity on an object.
We can actually know how much our plants are weighing that the astronauts will consume. So they use the Newton's second law of motion, which has force, mass, and acceleration.
Under the same amount of force, an object with more mass will accelerate less. So, to apply this in space, astronauts use the Mass Measurement Device, MMD, which launched to the space station in 2017.
They then put these plant samples inside a little Ziploc bag, and then the mass measurement device goes back and forth a few times.
The MMD applies a known acceleration to the sample and measures the resulting force, allowing the system to determine its mass. It can measure between 1 and 100 grams and has an accuracy of 0.1 grams.
It's wonderful. It's really, really accurate. So it's a great new tool that we have.
There are multiple mass measurement devices on the space station. They measure everything from astronauts who are monitoring their health to freshly harvested produce from the station's veggie growth chamber. So, when microgravity makes it impossible to tip the scales, it's mass that matters most.
So what is mass? Mass is nothing but the measure of its inertia. Greater the mass, greater the inertia. Okay. So it remains the same whether the object is on the earth, the moon, or even in the outer space. So mass doesn't depend on your place. Even if your mass is 40 kgs on earth, it will be 40 kgs on space. It will be 40 kgs on Mars. But when we talk about weight is different everywhere. Why is it so? Because weight, we'll study about it. It is dependent on G. And your G changes on every platform. G is different for Earth. Your acceleration due to gravity is different on Moon, correct? So your mass remains same whether the object is on Earth, the Moon, or even in the outer space. Thus, the mass of an object is constant and does not change from place to place. This is about mass. So mass is independent of location. Okay. It is not dependent on location. But when we talk about weight, so this is our universal law of gravitation, right? Earth attracts every object with a certain force, and this force depends on the mass and the acceleration due to gravity. So have you seen this formula? Force is equals to mass into acceleration. Which law was this? Second law of motion, right? So what is your weight? Weight is the force. It is a kind of force. Weight is a type of force. If weight is a type of force, then what should be its SI unit? Its SI unit should be newtons because the SI unit of force is newtons, correct? So the weight of an object is the force with which it is attracted towards the earth. Okay. It is denoted by W. As the name suggests, we take the first letter of the word weight. So it is denoted by W. Okay. So what is weight? Weight is it is a kind of force with which the object is attracted towards the earth. And this is due to universal law of gravitation, that every object attracts every other object, correct? So earth attracts every object with a certain force, and this force depends on the mass of the object and the acceleration due to gravity. So this is your weight is equals to m into g. And how do we get this? We know that from Newton's second law, force is equals to m into a. Correct. So when your force is equal to your weight, what is weight? Weight is a kind of force with which an object is attracted towards the earth. Okay, so when we are talking about this force, that is your weight, it is equals to mass into acceleration is g, because we are talking about how the object is attracted towards the earth. So your A is equals to acceleration due to gravity, that is g. So this is how we get W is equals to mg. And what is its unit? Newtons, because it is a type of force. Okay. So weight. SI unit of weight is same as that of force, Newton. The weight is a force acting vertically downwards. We know that gravity always pulls the objects in the downward direction. Gravity always acts in the downward direction. Okay. So it has, so weight, so do tell me, is weight scalar or vector? So we know that for weight is equals to mg. G is acting in the downward direction. What does that mean? That your weight has direction. So your weight has magnitude as well as direction. So what does that mean? That weight is a vector quantity. Okay. So it has both magnitude and direction. The weight of an object is directly proportional to the mass of the object. As we know, weight is equals to m into g. So it is directly proportional to mass, right? So if your mass increases, your weight increases, correct? For example, if your mass is 10 kgs, okay, your weight will be 10 into g. Your mass is 20 kgs, your weight will be 20 into g. So in this case, your weight is more, है ना? Correct? So your weight increases as your mass increases. Mass of an object remains same. As we know that your mass, it is independent of the location, but your weight depends on the location. Why does weight depend on the location? Because weight has g in it. Correct? Weight is equals to m into g. Since weight is dependent on g and g is different on moon, earth, etc., etc. So your g is different on different platforms. That's why your weight varies, but your mass is constant. So suppose if your mass is 20 kgs on earth, it will be 20 kgs on space. But if you're talking about weight is not same. Okay. So weight of an object on earth is the force with which the earth attracts the object. Correct. And what is weight of the object on moon? It is the force with which the moon attracts the object. So weight of an object on any platform is the force with which that platform attracts the object. Simply, correct. So the mass of the moon is less than that of earth. We know that mass of moon is less than mass of earth. What does that mean? That means that moon exerts less force of attraction on objects. If mass is less, that means your weight is less. If your weight is less, what does that mean? That your force is less, right? Weight is a type of force with which the platform attracts the object, right? If you're talking about moon, so, right, it is the force with which the moon attracts that object. If you're talking about earth, weight is the force with which the earth attracts the objects. So, due to the moon, due to the lesser mass of moon than the earth, it exerts less force of attraction on objects. So weight of an object on the moon. So let's calculate the weight of the object on the moon. Simply we know one formula, that from the universal law of gravitation, force is equals to gmm by d square. Right, force is directly proportional to product of masses, force is inversely proportional to square of distance between them. And when we put this proportionality constant, we get this formula, correct? So in this formula, let capital M is equals to mm, mass of moon, and let your small m is equals to your mass of object, whichever object we are talking about, okay? So what will be the weight on moon? It will be G, mass of moon, into what is mm? It is mass on moon, okay, into m, mass of the object, upon rm, radius of moon's square. So let the weight of the same object on the earth be we. So we are using these terms, okay. So we are using these terms. I'll just explain you. mm means mass on moon. me means mass on earth. What does wm means? It means weight on moon. See, w, weights initial, right? And what does we means? Weight on earth. So let's discuss now. So let the weight of the same object on the earth be we. Okay, weight on earth. The mass of the earth is m and its radius is r. Okay, mass on earth, let's it be me, and radius be re. So what will be weight on earth? Weight on earth will be gme m upon r square. So this is for moon, and for earth, change the initials, these are e. Okay, weight on earth is equal to g, mass on earth, into mass of the object upon radius of earth square, okay, re square. And when we are talking about moon, weight on moon is g, your gravitational constant, mm, mass on moon, into mass of the object upon radius of moon square, okay. So mass and radius of celestial bodies. So when it was calculated, scientists found that for earth, your mass is 5.98 into 10 to the power 24 kgs. See how much mass is it, 10 to the power 24. And your radius is 6.37 into 10 to the power 6 meters for earth. And when we are talking about moon, for moon our mass is 7.36 into 10 to the power 22 kgs. And your radius is 1.74 into 10 to the power 6 meters, okay. So let's calculate the weight of an object on the moon. So we know that weight of an object on the moon, this is your m, okay, is g into mass of moon into mass of the object upon radius of moon square. So we'll plug in the values, okay. We just saw in the previous slide that mass on moon is 7.36 into 10 to the power 22 kgs. And radius of moon is 1.74 into 10 to the power 6 meters. We'll do nothing but plug in the values, right? Right, simply we'll plug in the value in this formula. And what will we get? We'll put mass on moon 7.36 into 10 to the power 22 kgs. M is your mass of object, which is unknown. And your r square is 1.74 into 10 to the power 6 square. Correct? So this is how we'll calculate weight on moon. Substituting the values from table, we get weight on moon is equals to 2.431 into 10 to the power 10 g into m. Okay, after calculating, you will get this. You can use the calculator for the same. Okay, or otherwise you can just expand it and then solve. 22 into m upon 1.74 into 1.74 into 10 to the power 6 into 10 to the power 6. After calculating this, we will get that weight on earth is 1.474 into 10 to the power 11 g into m. Okay, and weight on moon is this. After this, we will just divide weight on moon upon weight on earth. And what do we get? That weight on moon is 1/6 times weight on earth. Are you getting this? What does that mean? That, for example, if you are very fat or you are very, if a heavy object is kept on space, its weight will become 1/6. For example, if a person's weight is, suppose 60 newtons, okay. If a person's weight is 60 newton on earth, okay. So what will be his weight on moon? Simply we will divide 60 by 6, because we know that on moon our weight reduces by 6 times, correct? So The weight will just be 10 newtons. You lost, 6 times the weight on moon. You lose, right? So it will be just 10 newtons. So weight of the object on moon is 1 by 6 the weight on earth. It is very, 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 very important. Okay. So let's do this question and you people have to tell me this, okay? Mass of an object is 10 kg. What is its weight on earth? Okay, firstly, we have to calculate the weight on earth. We know mass is 10 kg. If we have mass, can we calculate the weight? Of course, we know that weight is equals to m into g. Correct. And where g is your acceleration due to gravity. G is equals to 9.8 meter per second square. So use g is equals to 9.8 meter per second square. And if it is mentioned in the question that use g is equal to 10 to make your calculations easier, then only use g is equal to 10. If it is not mentioned, use g is equals to 9.8 meter per second square. So what is your weight? Is equals to mass into 9.8 is equals to 98 newtons. Okay. So question number 2. An object weighs 10 newton when measured on the surface of Earth. So your weight on earth is 10 newtons. What would be its weight when measured on the surface of the moon? We know that on the surface of moon, we reduce our weight by 1 by 6 times, right? We reduce our weight by 6 times, correct? So our weight becomes 1 by 6 times the weight on earth. That is your 10 by 6. That is your 1.67 newtons. Correct. 1.67 newtons. See, a 10 newton person became so light on moon, correct? So, on moon you lose weight. On moon, you lose weight by 6 times. Like 1 by 6 times. Correct? Your weight becomes 1 by 6 times. Weight on moon is 1 by 6 times the weight on earth. So let's do this question. What are the difference between the mass of an object and its weight? It's a very, very simple question. We know that mass is constant value. Mass is independent of location. Correct? We saw, no, that, mass is same everywhere. If we are on Earth, on Moon, on Mars, on Jupiter, on anywhere, your mass is not dependent on your location. It is independent. Your mass is constant. But your weight is dependent on location. It varies, correct? Because why is it so? Because your weight is equals to m into g, and your g is different everywhere, right? So simply, and mass is your scalar quantity, correct? Why is mass scalar? Because it doesn't have direction. And your weight, weight is equals to m into g. And g always acts in downward direction. So weight has direction. What does that mean? That weight has magnitude as well as direction. And what does that mean? That weight is a vector quantity. Correct. What is unit of measurement? SI unit of mass is kgs. And what is your SI unit of weight? SI unit of weight is newtons. Correct. So gravitational effect, mass does not depend on gravity, right? And your weight depends on gravity because weight is equals to m into g. Mass can never be 0, but your weight can be 0. Of course, if there is no gravity, okay. So tell me, if there is no gravity, for example, in space, there is no gravity. What does that mean? That your g is equals to 0 in space. What does that mean? That your weight is equals to m into g. Whatever your mass, for example, you have 1000 kg mass, but your g is 0, right? So your weight will become 0 Newton, right? That's why people fly in space, right? They have no weight. They are weightless in space. Why so? Because we have g is equals to 0 in space, correct? We don't have gravity. So your weight can be 0 because your g can be 0. But your mass can never be 0. So mass can easily be measured using any ordinary balance. For example, your weighing machine also. You call it weighing machine, but from now you know that that's not your weight, that's your mass. Okay, mass can be easily measured using any ordinary balance. Weight can be measured using a spring balance and its formula. Okay, I hope it's clear. It's very clear, right? So let's see this question. Why is the weight of an object on the moon 1/6 of its weight on the earth? The mass of the moon is 1 by 100 times and its radius 1 by 4 times that of earth. So we saw the mass of moon and mass of earth and radius of moon and radius of earth in the previous slides. And we get to know that mass of the moon is 1 by 100 times the mass on the earth. And it is 1 by 4 times the radius on the earth. As a result, what will happen? Gravitational attraction on the moon is 1/6 when compared to earth. How do we calculate the gravitational attraction? By this. So since your mass on moon is also less than earth and radius on moon is also less than earth. So obviously our force, our attraction, gravitational attraction will also be less. It is also 1/6. So the moon's gravitational force is determined by the mass and the size of the moon. Hence, the weight of an object of the moon is 1/6 the weight on the earth. The moon is far less massive than that the earth and has a different radius r as well. So let's study a new topic today, which is thrust and pressure. So we'll study this in the next class. So till then, till that time, do revise whatever we have studied till now. And bye-bye, have a great day and do revise.